Today we are going to talk about one-way ANOVA between subjects using RStudio Cloud. As you notice that on the screen, if you type RStudio Cloud, you will get to a page asking you to sign in. It is very simple step, and after that it will get you to this web page that you are looking at now. If you go ahead and click on new project here and new RStudio project and then give it a name, it will create a project for you like this. I gave it a name called workshop, so immediately I will click into that, so it will open the RStudio web browser for me. The RStudio Cloud is different from the regular RStudio and R. It doesn't require you to install the actual software on your computer. It's a web browser, and it gives you specific storage that is enough, I guess, for today's workshop at least, that you can log on from any other computer and still continue working on your project. Anyway, without further ado, I will briefly explain these four windows. You might find the first window look like this. So you need to break them down by clicking on this small two windows here. So you get two windows. One is called the source, which is the one on the top, and this is the console. Whatever you type here will whatever you type here, or whatever equation or code you type here, you'll get the result here. So let's say start simple, like 2 plus 3, and then I will click run. Here is the result. Okay, let me clear that first. When you click Control L, it will clear the console. Again, I need to put the cursor here. Remember, if the cursor is here, it will not work if you hit run, because this is empty. I need to put the cursor anywhere on this line is fine, and then click run. Now I get the result. And let me do another thing. If I name this A equal 2 plus 3 and hit run, it doesn't give me any result because I didn't ask for the result now or yet. I just stored this equation into this letter. So if I click A here and then click run, it should give me number 5. Yeah, it is just late. Sorry, let me just restart. So click 3 and then go on A is supposed to be here like 5. I could do like 5 minus 2. Okay, 3, and so on. Okay, you just clear that. I don't need that anymore. Let me just briefly explain the study that we have that we are gonna work on. It is in an Excel sheet. As you could see, this is the Excel sheet. I made a very simple study. This is fake data. This is just for the purpose of this workshop, I would say. So I have this researcher would like to see the effect of different movie types on second language learners' performance. So imagine that you have a second language teacher who would like to see whether the type of movie that given to L2 learners would influence their second language comprehension or interaction or motivation. and he or she decided to get clips from three different movie types: comedy and action versus horror. So we have three types of movies, and we have the results here. After watching each type, participants were given questions in order to see which movie attract their attention more or attract their interaction more. So they paid more attention, and therefore that influenced their results, as you could see here. And here are the ID of the participants. Now, you see here age. I'm not going to talk about that now, at least not today. Maybe in our next session, I would use date, but age. But now, it is just one factor, which is movie type with three levels: comedy, action, and horror movies. And here is the ID list of these participants. We have different participants in each group. So group 1 is from 1 to 24, group 2 from 25 to 50, and then group 3 from 51. This is called between subject design because the participants in each group are different. If I have the same participants, then I would copy from 1 to 24 and put it here, number 1 to 24, which is called within subject or repeated measure. So, briefly explaining that design, I have ID, which is the participant number. Movie type, I have three levels: comedy, action, and horror. And here are the participants' results. I will go back to my RStudio, and let me just clean that. When you click on this broom, it will just clean everything. And I would like to upload this Excel sheet into my RStudio. I will go to Files here, and then I will go to this plus sign, actually to this arrow sign, and click on it in order to upload the file. Choose File from here. I would go to the file, which is, as you can see, it is data here, and click on it and then hit OK. Now it's supposed to appear here. Yes, that's the one here. That's my data. I cannot read it yet. I need to do something before being able to read the data here. Since it is an Excel sheet, as you could see, in R we need what is called packages. A package, some packages are installed already by default, but a number or the majority of packages are not. You need to install them and activate them because it takes some space in your R memory. So in this case, I would like to install a package called or install a package for reading the Excel sheet. So I would do like install .packages, as you could see in the drop down list. I'll click on it, and between quotation marks I would write read Excel. This is a package. I need this package in order to read this Excel sheet, and put the cursor anywhere and hit run. When you hit run, here it gives me a message, a warning message, because this is already installed in my computer and asking me whether I need to reinstall it again. No, I don't need that. But you need to hit run and keep it installed. When it is done, activate this package by writing require read Excel. You need to activate it. When it is installed, it is there, but it's not functioning yet. It's not working. You need to activate it. So require read Excel. You didn't need quotation marks here, only when you install it. Click run. Now it is activated. One note: whenever you install a package, you don't need to reinstall it every time you want to work on your RStudio or R in general. You just install it one time, unless you update your whole R software. You need to reinstall all packages. It's like, I would give an analogy, it's like your phone. If you have a smartphone, once you install a software or an application, you don't need to reinstall it every time, unless you just erased everything on your phone. But you need to activate it every time. Whenever you start or restart working on R after closing this window or this web page or the software, you need to click on require again to install it. So in order to avoid reinstall the same package over and over, I would click the hashtag in front of it. In R and RStudio, whatever you write after a hashtag, it is deactivated. It doesn't work anymore. It is just deactivated. See, if I hit on it again, it doesn't work. Let me just give another example. 3 minus 2. They want to run it. Let me just delete this for a second. Now, okay, it's giving me error. It doesn't work. Okay, so this is a good thing for you if you would like to write note, for example. If you would like to write any note. Okay. Going back to our require read Excel, and I will just activate it. Now it is activated. I will go ahead and I would like to read the data sheet or the Excel sheet that I have. I will give it a name. Here it is named data. I will call it like my data. You could give it any name you would like, whatever name you would like to, for example, give it John. It's up to you. So I would read just sort of my data. However, be careful of the spelling, because R is case sensitive. If this D, as you notice, is capital and this M is capital, you need to make it capital all the time, or make them capital all the time when you read or when you need this data. So I'm saying that my data equals read underscore Excel, and then between quotation marks I would write data dot XLSX, which is this one. It's supposed to be the same exact spelling, data with capital D dot XLSX, okay, between quotation marks. If you mess up the spelling, it will not read it because it doesn't know what are you talking about. So I will hit run here. Now, as you notice here, it is installed here. It is installed. It's showing up here. Now it is just stored. Everything here is stored in my data. Let me try to see if it is the same data that I have in the actual Excel sheet. write view with capital V, view with capital V, and then my data. Remember the same spelling here and here, supposed to be the same. I would like to view this, what is inside my data file. Then make sure the cursor is somewhere here, then hit run. When you hit run, a new window will pop up, and as you can see, you have the same ID and movie type, comedy, action, and horror with 47 participants, and results the same. We still have age, although we don't need it, but because it is part of the Excel sheet, it is there as well. Okay, going back here, as you can see here, my data, because I hit view, it is here, and then go to untitled. You could name it here again. If you click save on the current document here, save, and just save it. Give it any name you would like. Movie data, for example. Okay, now it is saved here, movie data, and it is now called movie data. That will save it for you. And then I would like to see or use another code to check the data. I would write head and then my data. This will give me, let's say, I would like to see the first 5 rows. So head, comma, 5, click. Now see, these are the 5. If I would like to go with the 10, first 10. Okay, I have the first 10. If I would like to see from the bottom or the tail, I would write tail, my data. I would like to see the last 5. Click run. This is the last 5 rows, and so on. This is just to check your data. If you would like to see, as you notice here, in row, I would say, yeah, here we have NA in row 34. This is blank. I did that deliberately. I made it blank, but I didn't know how many of these are blank, how many blank cells I have. So to check that, just write which is between brackets is NA. Is NA, which cells has NA, which is 0 or no data or empty, and then my data, comma, comma, R or AR, ARR dot IND equals true. T or true is the same. It should give you the same result, which means that which cells are empty. Give me the rows and the columns of these cells. So run. If you could see here, give you row 34, column number 3, row 54, and column number 3. Let's go ahead. Row 34, yes, column number 3, 1, 2, 3 here, and 54 and 3, 54, here it is, 54 and 3. These are empty. It is easy for this data to check them just without a code, but imagine if you have thousands of cells. It is not an easy task to do, to find out all empty cells without this code. Now, I would like to check the data to see the mean and the numbers of participants and the standard deviation and so on. I would install another package called psych. The psych package includes what's called the descriptive function. So again, click run, and after you install it, you could just deactivate it by putting a hashtag in front of it, and then go ahead and go require psych. Okay, I would like to require psych, run. Now I activated psych package. I will go ahead and write describe and describe my data. That should give me a descriptive result of my data. As you can see here, let me just go do this again. I'll just give myself some space here. Okay, now I have ID. How many of them? 47. I have movie type, I have age, and have result. This is star here, meaning that this is not a continuous variable, or not a numerical variable, actually I should say, because movies is not a numerical variable. It is comedy, horror, and action, while others are numerical variables. So the result is here. The average, on average, all movies, the average score or result is 42.91. Standard deviation 15. Let's say minimum, the lowest score is 20, the maximum is 73. And here we have the skewness and kurtosis. Skewness and kurtosis. We will get to that when we are back. So here is the kurtosis and here is skewness. Well, now I have the average of all movies, which is 42.91, and the median is 42. I would like to see each movie individually, the average of each movie. The same, I would go describe by, I would use the capital one with the word B, describe by my data, comma, my data, $sign, and after the $sign, I got the drop-down list of my variables, the drop-down list of the variables inside this folder. So I need to describe by movie type. Okay, and click run. Now, as you can see, here I have the action movie. The average is 38. The median is 40. The minimum is 21 and maximum is 66. Then comedy, the average is 30 and so on. And horror movie, the average is 59.54. Okay, and the movies are listed by alphabetically. So action started with A, comedy started with C, and horror started with H. This is why they are listed, not by the average or anything. It is just alphabetically. So this would make it easier for you to see the average of each individual level or movie here. Now, I would like to compare them statistically to see whether the difference between these three movies is statistically significant, whether the result is statistically significant between comedy, action, and horror or not. I will use what is called one-way ANOVA, one way between subject. And as I mentioned earlier, between subject, meaning that the participants in each group are different. So I would go ahead and write a title here. I would go like one way between subject, sorry, ANOVA. Okay. Okay, I would go ahead and write the ANOVA code. Again, I will write like my ANOVA. I could name it anything. Equal. I'm just give it a name that I should use throughout this session whenever I need to go back to the ANOVA analysis. And I would type AOV, comma, brackets. Now, what I would do is I will put the results or the score or whatever that the outcome, the dependent variable here, predicted by the independent variable. Okay, this is how it works. So the dependent predicted by the independent variable, or if I have more than variable, I would go like independent variables. So my dependent variable here, let's go back to the Excel sheet here. The dependent variable is the result, right? This is the dependent. It depends on my factor, which is movie type. Okay, so I would write result. Is it result or results? It's supposed to be, it is really spelling sensitive, so be careful of the spelling. Here it is. As you can see here, this is the result. So I would go and copy and paste it just to make sure I'm not missing anything or the spelling is the exact same spelling that exists in the Excel sheet. Then I would type tilde. Tilde means predicted by or explained by. Result explained by. I want to explain it by movie type. Here is the movie type. Just copy and paste. You didn't need the star. Okay, now ANOVA explain the result by movie type and where the data is, because ANOVA doesn't know where the data is. You need to tell this function where your data is stored. So you would write data and giving you here data equal, it is stored in my data. And as you notice, it is the same spelling as the folder up there. My data, the Excel sheet, is stored here. So my ANOVA, which is the name I gave it to this one way between subject ANOVA analysis. AOV, which is the code for ANOVA, between between brackets, result predicted by movie type, comma, data equals my data, and hit run. Again, nothing appears yet because I just stored everything here in my ANOVA. I would go ahead and write summary, copy, and do the same, my ANOVA, with the same exact spelling. Now I get a result. As you could see here, my ANOVA is statistically significant. Some people get what's called scientific notation. Scientific notation doesn't give you the full, like the overall number in this format. So you might write, if this is the case, write option SCPN, yes, SCIPN, right, equals, sorry, options SCPN equals 999. This should do the work in case you get a scientific notation. options is CI PEN equals 99, but I don't need it because it looks good here. Now, this is statistically significant. What does that mean? If my p-value, the p-value is less than 0.05, that means there is a significant difference. There is a significant difference among the levels. That means there is a significant difference between comedy, action, and horror on the results. So that what does that exactly mean? It means that the participants perform differently after comedy, after horror movie, after action movie. They perform differently. Okay. If it is more than 0.05, it means that there is no significant difference between these levels. It doesn't mean that the average of each movie is the same. No, it doesn't mean that. But the difference is not significant. Okay, I'm not gonna go in details why we compare it to 0.05. You might type like alpha 0.05 and see what is the explanation behind it. Generally speaking, it says that we are 95% confident that the result is caused by the factor we are using, not by other factors. Okay. Now, I would like to go ahead and see the difference between these movies. So now I have action movie. Okay, let me just write it here. Action movie does not equal, is not the same as, whether the result based on action movie is not the same as comedy, and this is not the same as action movie, right? So we don't have the same statistically not this actually there is a significant difference between the results based on these three movies. Well, if I go back to the averages here, action is 38 and comedy is 30 and horror is 59.54. Okay, but which one is actually different? Maybe is the difference between all of them, two of them only? We don't know yet. So what we are gonna do, we will do what is called post hoc comparisons. Post hoc comparison using what is called two-key HSD. Two-key HSD. With two-key, you didn't need to install anything. It is already installed by default in R. So what would I do is I would write two-key HSD and then perform that on my ANOVA, which is my initial ANOVA analysis. So two-key between brackets my ANOVA and click run. Now you get comparisons between the three levels. Well, here as you could notice that two-key multiple comparisons of mean 95% family UI's confidence level. It compares comedy to action and that is statistically significant. The p-value is statistically significant. There is a significant difference in the results between comedy and action. Between horror and action, the same, because it is less than 0.05, and the same between horror and comedy. So there is a significant difference between each two levels, and which one leads to, or which one resulted in the highest performance among these participants? Let's just go back to the descriptive by, or describe by, and compare the mean. So we have the action 38, and we have the comedy 30, which is the lowest, and we have horror, which is 59 something, or almost 60. So horror movie resulted in the best performance, which is almost 60 points, and followed by action movie, which is 38.92, and then by comedy, which is 30.58. Again, this is just the fake data for this session, but this gives us an idea of which level leads to the best performance, although there is significant difference between each two level, or two levels actually. Now I would like to make a plot or box plot for this result. I will install another package called ggplot, install packages, and between quotation marks ggplot2, and hit run. I don't need that again. I have already installed this package, and after you install it, just activate it. Require ggplot2, or actually ggplot. You don't need 2. Let me see, do I need 2? Yeah, ggplot2. Yeah, it gives me error. I need to add 2. Okay, ggplot2. Now I would like to make a plot for this data. Let me just give it a name. Movie plot. Just this is a name I choose to store the data in. Then I would go with ggplot. Okay, it's here in the drop down, and then my data, comma, AES, between another bracket. I would say the x-axis equals movie type. Why movie type? Why I write it this way? Because if you go back to the data, it is here, movie type, movie underscore type, with M capital and T capital. So it's the same with the x-axis. Okay, comma, the y-axis equals result, my result, which is here with capital R, result. Okay, and just give another comma and go down. It's okay to go down. Type fill equals movie underscore type, and I'll show you what does that mean in a second, plus GEOM underscore box plot. Okay, I'll leave it here. if you go anywhere here and click run, now it stored all these all this code in movie plot. Now I'll go down, I'll copy this and paste it here, and just give some space here and click run. Now I have the result here, or the box plot. You could notice I have the 3 different movies or movie types. I have the result here on the Y axis, and I have movie type on the X axis, and here is movie type, which is fill movie types is here. So movie type action comedy movie, although they are written here, but this is called legend. It is nice to have them on the side as well with different colors. Okay, now as you notice here, there is no title, and also, okay, let me see, yeah, there is no title, and I don't like the underscore here, movie type, and I don't want the word result. I want to change it with a different name. So I would like to get a title and change the x-axis and y-axis names as well. So I would do the same, but I will call it movie plot number 2, now another one, and add the previous one, which is movie plot, meaning that everything here, I want this, I just need to do some changes on the same box plot. So I use the old one or previous one, add plus, and then I type labs title equals movie, let's say, between quotation marks, movie for L2, because as you remember, this is a study made for second language participants in order to see their performance after watching comedy versus horror versus action movies. And then comma, this is for the title, and I would like to change the x-axis. I would go X, and then I would go like movie, sorry, just give more space here, movie type with no underscore, and then I'll give comma and go down a little bit. Y equals, let's say, instead of result, as it says here, result, I would say score or performance. Just write score. Okay, and also I would like to change the legend here. Instead of movie underscore type, I just want the word movie. I just want the word movie. Go close the bracket and plus another labs fill equals movie or movies. Okay, and labs, and I'll click run. Okay, now it doesn't show anything yet. I just stored everything here in movie 2. So I'll go to movie 2, put it down here, and click run again, and just give some space in order to. Now, as you can see here, movie 2, which is my title, movie for L2 actually. The x-axis is movie type with no underscore, and then score, and labs movies here is movies. Now looks nice. As you notice here, this is not in the center. I don't know how to make it in the center, but What I would do is just move it here after the quotation mark, just create space and see if it works. Let's see. Okay. No. Not really. I'm sure there is a way to do that, but I don't know how to do it, to be honest. But that should, oh sorry, yeah, run it and then go back to movie here, movie plot 2. Okay. Oh sorry, I did the wrong movie for L2, this one. I want space here and go to movie back, click run. Okay, move it a little bit. Okay, that's better. I'm sure there is another way to do it better than just creating a space in the quotation, inside the quotation mark, but that should do the job. Another code, if you would like an easy and nice way to get the overall means, just write model dot table or tables, and then my ANOVA with the same spelling, comma, between quotation marks, write mean, and click run. Now you get the averages of each movie. Action is 38.92, comedy is 30.58, and so on. These are. And here are the number of participants in each group. We have an equal number of participants, 26 participants in the action movie and 24 for each of the other type. Now I would like to move to what is called the effect size. The effect size is the effect of our factor on the results. The effect of the factor, which is movie type in this case, on the results. So we just write here effect size, which is an important component when you report your results. Install packages. Again, it needs a package which is called LSR. So you click here and it will be installed. I don't need it because I already installed this. And then require LSR in order to activate this package. Run. And in one way between subject ANOVA, we get what is called eta squared. Eta squared. Eta squared measures the effect size for my ANOVA. Okay, click run. Now you get the eta square here, which is 67, which is considered high. It indicates that 65% of the result explained by the factor that we are manipulating. You might go ahead and search for eta squared, the importance, if you don't have enough information about it. I'm not gonna go deep into theoretical aspects of each component, but you are welcome to go ahead and search for how to interpret effect size for ANOVA. ANOVA has assumptions, so we need to test assumptions here. As you know that one of the assumptions is the normality of the residuals. We extract the residuals first from our data. So I would go like my data, $, and residual or resids. This is the code for residuals, RESIDS. Then equal, or this is actually creating a new column for the residuals. I create a new column for the residuals. I would write residuals. You could see here residuals. my ANOVA. I'm just creating a new column called resids in the same data with the residuals. So I click run, and if you go back to my data again, you will see the residuals here. A new column is created. This is only in the RStudio. It's not created in the original Excel sheet. So you might save this later in your desktop. But this is just here on this window. Now, I would do what is called Shapiro test. Shapiro test is the test for what is called test for normality of the residual. I would like to see whether these residuals are normally distributed, because this is one of the ANOVA assumptions. We need to see whether these residuals are normally distributed. So I would do like my data at residuals, which is this one. I extracted the residuals here and saved them here, and now I'm performing Shapiro on this result. As you can see, the p-value here is 0.3226, which is greater than 0.05. 0.05. Let me write it here. Greater than, which means that there is no significant violation of the normality assumption, which is good. We don't want the result here, the Shapiro walk normality test, we don't want it to be significant. We want it to be less than 0 or greater than 0.05. If it is less than 0.05, it means we have a significant violation of this assumption. If it is not less than 0.05, that means there is no significant violation of the normality of the residuals. The other assumption of ANOVA, which is homogeneity of variance. Here, let me write this one. Normality of the residuals, residuals. And the other one, which is homogeneity of variance. Homogeneity of variance. So, I don't know. Yeah, yes, that's correct. Homogeneity of variance is the statistical assumption of equal variance, which means that the average squared distance of a score from the mean is the same across all groups sampled in the study. In other words, the population variances of the groups or cells being compared are homogeneous or equal. As you notice that we have different participants, different number of participants in each group, right? Or at least in one group. If you have one group has way more number of participants than others, that might create a problem in terms of these two assumptions. So we want to check in case whether we have a violence of the homogeneity of variance. We install a package called CAR. CAR includes this test called Levene's test, which is the test for homogeneity of variance. Again, I don't need to install it here because it has been already installed, but I need to activate it. Require CAR. Okay, run. Now CAR is activated. I will go with Levene's test, this one with a capital T, and write the same ANOVA or the same code that I used for ANOVA. Result predicted by movie underscore type, and get the data from my data. Watch out for the spelling. Make sure that the spelling is the same, capital R, as it is in the Excel sheet. And then click run. Don't worry about the warning sign here. The p-value here is 0.1637, which is also greater than 0.01, which means that there is no significant violation of the homogeneity of variance, which is great. You don't need that to be significant. So you don't have a problem here. So this is everything related to one-way ANOVA. Maybe in the next session we will talk about either one-way within subjects or two-way ANOVA. Please, if you have any question, contact me, and I'll be glad to answer your questions. Thank you so much.